Okay, so what is parabola? 10.1 parabola. We learned about parabola a long time ago, even before test 1. Now we will see we have a deeper look into parabola. Okay, and we start first with a definition. What is a parabola? A parabola is the set of all points in 2 dimension, of course, equidistance, same distance, to a fixed point that we call focus, and a fixed line, which we call directrix. Okay, let's see. I will, give me a second. Let me change my view. Let me borrow the coordinate system. No, that's too fine. Okay, let's use this one. Okay, so let's start with this. Suppose I have a coordinate system. Okay, and I will put my focus here. I'll put my focus there. Okay, where the focus is 0, k. And then the directrix is y equals to negative k. Now, I purposely use this for now because then one of the coordinate, the vertex of that parabola will become 0, 0. That's the vertex. But notice that the distance from this vertex to this point is k units. The distance from this vertex to the line also k units, right? So this point here, 0, 0, is one of the point on the parabola. Okay. Now we have another coordinates, the coordinate here. Notice that this coordinate is twice k unit from the focus and also twice k units from the line. Do you see that? Okay. Now by symmetry, of course, that you have this coordinate here, right? Now the thing is there are actually a lot more coordinates, infinitely many coordinates for that. One of them, another one is here. So if you kind of sketch the graph, this is the parabola. Now visually you can see that the distance from this point to this point is 5, like 4 to the right, 3 units up, right? Okay, so the distance from focus to that point is 5. Now notice that this is also 5 units, right? Do you see that? Okay, now let's backtrack a little bit. We will try to find the equation of the parabola. Okay, we will find the equation of the parabola. Now we'll start with, let P, point P, be on the parabola? Let Pxy be a point on the parabola. Now we know the distance from the focus to that P, call that D1, that is equal to the square root of x minus 0 squared plus y minus k squared. Is that right? That's the distance from xy to the focus. Now, on the other hand, d2 is the distance from the point to the line. But you can see the distance from that point to the line is simply y plus k. Why? Because the length here is y, the length here is k, right? This is y, this is k. Now set them equal to each other. D1 equals to D2. By definition of parabola, D1 equals to D2. Is it okay? Now, I will look for the equation. So D1 is square root of x squared plus y minus k being squared, while D2 is y plus k. I square both sides, I get x squared plus y minus k squared equals to y plus k squared. Okay, now then let's FOIL that. There are actually another way to do it, but I think the more obvious one is I FOIL that y squared minus 2ky plus k squared equals to y squared plus 2ky plus k squared. Y squared, k squared cancels, this cancels this cancels that. Okay, so we have x squared equals to 4ky. Now, what is this then? So if you see an equation x squared equals to 4ky, it means that first opens to positive y direction. If the 4k is positive. Okay, and then the distance from the vertex to the focus is k. In fact, this 4k has a name. This 4k is called focal width. Focal width. that 4K, this 4K here represent the length here. That's the length of the chord passing through the focus. Okay, and perpendicular to the axis. That's the focal width. That's the length. You can see, right? So you see if this is K here, this is 4 times K. Okay, now, so the distance from vertex to focus is 1/4 the focal width. Okay, now, how do we use this though? How do we use this? How do we use this? Now, suppose we go back to the basic. Long time ago, for example, we have, call that example 1, we have y equals to x squared. We know what the graph look like, but can we locate the focus? Find the focus and directrix. We know the parabola looks like this. So approximately like this. Now, then we know the focus must be somewhere here, right? Okay, but, and the directrix must be here. Now the thing is, can we find the coordinate for the focus and the directrix? We start with the vertex solution. The vertex is 0, 0. Now then, the coefficient of the linear part, in this case the y, that's the 4K. Right? So the distance, the K is 1/4. That's the distance from the vertex to focus. So where's the focus? The focus will be 0, 0 plus 1/4. See, if I enlarge that, if I enlarge this, the distance here is 1/4. Therefore, the distance here is also 1/4. The directrix y equals to -1/4. Okay. What happened if on Tuesday when we come back, we will talk about this again. We'll talk about this again, more problems, okay? But right after this, later on, I will show you why we study this. Okay, suppose I have y squared equals to 5x. Now you see that the x is the linear part, okay? And the coefficient is positive. So this will be opens to positive x-axis. Now we know from the equation the vertex is 0, 0. So the parabola will be, if I sketch that, the parabola will look like this. Okay, that's the parabola. Now coefficient of the linear part is 5. So 4K equals to 5. So K equals to 5/4. Okay, which means from the vertex to the focus, you move to the right 5/4. So focus will be 0, move to the right 5/4, 5/4, 0, and the directrix is y equals to -5/4. Okay, now why do we learn parabola? Why do we learn parabola? Why parabola? After circles, parabola, in my opinion, is the second most used shape, paraboloid in 3 dimensions, the second most used shape in engineering. Okay, the first reason, and actually this is just the same reason with the second one, is the following. The first reason, suppose you have a parabola and you turn on a light at the focus, a light at the focus. The way it behaves is the light will go to every direction, but once it hits the parabola, it will be reflected parallel to the axis of the parabola. Will be reflected parallel to the axis of the parabola. Now, imagine your headlight of your car. The mirror at the back of the light of your headlight of your car is actually parabola shape, because otherwise, if it is not a parabola, then the light from your headlight will go everywhere. No, that's not what they want. So they control that a little bit. Of course, they distort the parabola a little bit, okay? But they control it in a way that the headlight will not go up, but it goes horizontally. So the driver in front of you, if you have a car in front of you, okay, the light will not hit their rear view mirror and blind them. Okay, that's also the reason. One way to know if you are planning to buy a car in future, okay, how do we know that car never have an accident at the front end? Take a look. Turn on the light. Turn on the light. If that car never have an accident, then the light will be like this. Now, if it already have an accident, then one of the light will go up, or at least then the light will not be the same height. You see, one light may be shining up and the other one is actually still flat. That's how we know that that car has an accident at the front end in the past. It is possible that the title is clean, right? Like when we say clean title means that car never have a major accident that requires the owner to report to DMV, right? Okay, but if some people just so good in hiding that fact, such that of course they don't report it, they just pay on the spot. They make kind of like a settlement, right, with between those two owners. Okay, so if you check the title is clean. Okay, now why, Thomas, you look at that? Don't you think that person can go to mechanic and then just solve this problem? Yes, the mechanic can solve this problem, but the issue is it's so hard to make them exactly the same unless it is from the factory. It is very, very hard. Now, if you want to be somebody who actually fix a car professionally, then pay attention to this one. If you can make the front end accident cars, the car with front end accident, if you can make the headlight actually the same height again, Like just turn it on to a wall and see the left eye, the right eye, you know, the left light, the right light, do they get the same height? Okay, not just a little off, exactly the same. If you make it exactly the same, that's actually how you cover the fact that that car already have a front end accident. Okay, now that's one. Now for the same reason, if you have a parabola and this is the focus, and you have a lot of lights or signal coming from very far distance to the parabola, then those signals will be reflected to the focus. Those light will be reflected to the focus. Okay, so if you have satellite dish, they use paraboloid. That's basically from parabola shape. And the receiver is actually placed right at the focus. Now, Thomas, you talk a lot about technology. Okay, well, let's talk about something not technology, but still use parabola. Okay. In some places, including remote area in Indonesia, when they cook, they don't use gas. Yeah, you can say they can just use wood, right? But some of them don't even use wood. They actually use a big wok as a mirror, and they put the what you call that, let's say the plate, the food that you want to cook right at the focus, and they use sunlight. So the sunlight will reflect that to the focus where you put the food. So the sunlight is not that hot, but if you concentrate that to the food, then it actually warm it up really, really hot. I mean, I have seen myself with my own eyes how a big wok, but they actually, they polish this, they make this into like a mirror, okay? And the food here get burned. Not only heat it up, I'm talking about get burned. Okay, because there's little heat, but concentrated in one place. Okay, now then eventually it's cooked, and if you leave it alone for too long, it's burned. Okay, now that is a clean energy. Okay, you don't even burn a wood, right? You don't use fire. You create fire not by using fire. Okay, you just concentrate the sunlight and then food. Now, of course, the weakness of this way of cooking, the weakness is you cannot cook instant noodle at night, right? In fact, you can only cook when the sunlight is near the peak, like nearly 90 degrees. Then you can use this method. Okay, so this is in very remote area in Indonesia. I know in other countries they use this also. Okay, nothing to know, right? Okay, so we learn something for a purpose. Okay, I will stop here. That's about time anyway. I don't give you suggested homework yet for this parabola. Okay, we will do this, continue on Tuesday. Again, parabola material 10.1 and 10.2 will not be in your test 4, but it will be in your final. On Tuesday, we come back, we'll continue with 10.1 and go on with 10.2. Okay, that's for today. See you then.